Hello everyone, welcome to my channel Similarity. So we will be starting matrices today, and matrix is a very broad topic. So I have divided this whole chapter into four different videos, and in the first two videos we will basically learn about the theory of matrix. Basically we will study the theory part, and in the next two videos we will see some examples of matrix in Houdini. Okay. And before I begin, let me tell you that matrix is actually a very important topic, and if you want to create some very advanced setups in Houdini, I think matrix is something you definitely need to know. And also many nodes in Houdini actually behind the scene utilizes matrix in some way or other. So if you understand this thing, you basically understand how Houdini works internally. Okay. Okay, so let's start this. And in this video, I will teach you what is matrix, application of matrix, order of matrix, types of matrices, property of identity matrix, transpose of matrix, and addition, subtraction, multiplication of matrix. Okay. Okay. So the first thing we have here is what is matrix. So basically, matrix is a representation of data where data is arranged in the form of rows and columns. Okay, let me repeat it again. Matrix is a representation of data where data is arranged in the form of rows and columns, or you can say in the form of a grid. Okay, so if I have to create a matrix here, it will look something like this. We create two brackets here, and then we write all the elements of the matrix here. So the first element will be let's say 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so this is how a matrix looks like, and these are the elements of matrix. And also you can see here we have total 1, 2, and 3 rows. So these are the rows, first row, second row, and third row, and these are the columns. Okay, first column, second column, and third column. So these are the columns. So you can see here, this is how a matrix looks like. We have bracket here, and then we have all the elements here arranged in the form of rows and columns. Okay, so this is how a matrix looks like. Now the next thing we have application of matrix. So basically if I have to tell you one of the very let's say famous application of matrix is an image. So let me move it here. Okay, so let's say if we have a image here of a guy standing, let's say this is a grayscale image. Okay, then we can represent this image in the form of a matrix. So we have matrix here, and this matrix now represent the pixel value for each of these pixel present in the matrix. So let's say the first pixel has a grayscale value of 10, and as you know that grayscale value goes from 0 to 255. So the first pixel has a grayscale value of 10, the second pixel has a grayscale value of 5, similarly the third pixel has a grayscale value of 6, and so on. Similarly, let's say there is a pixel here in the uh, second row and first column. It has a pixel value of 6, so we can represent it in the form of matrix here. Similarly, let's say we have pixel in the row number 110 and column number 116, and it has a pixel value of 0, let's say. So we can represent it somewhere here in the matrix, and it has a pixel value of 0. Okay, so this is one of the application of matrix. Basically we can represent an entire image using a matrix. Okay, because we know that matrix is basically nothing, is just a representation of data in the form of rows and columns. Also not only for even this grayscale image, even we can use this for colored image also. So if this image is colored, then it must have a 3 channels, red, green, and blue. So for each of these channels also we can represent this data in the form of matrix, right? Let's say this green channel has a value of 1 in 1 for the for the first pixel, and let's say it has a value of 0 for the second pixel, and similarly like this. Okay, so this is one of the application of matrix. And also in Houdini the matrix is used to represent a data, right? So a matrix can represent a rotational data, or a translational data, or a scale data, right? And don't worry, once we jump into Houdini, then we will see how these actually looks like. Okay, So these are some of the applications of Houdini. Sorry, the application of matrices. And now let's see what is the next topic. Order of matrix. Okay. So let's say we have a matrix here that looks like this: 1, 2, 3, 4, 5, 6, 7, 8, and 9. And you can see here we have total 1, 2, 3 rows and total 1, 2, and 3 columns. So the first number here represent the number of rows, and the second number here tells us about the number of columns. So this is what the order of matrix mean. Basically, the order of matrix tells us how many rows or how many columns the matrix has. Okay. So let's say if I create a matrix which looks like this: 1, 0, 0, 1, 0, 1. So you can see it has total 2 rows and 2 columns. Okay. So this is the order of this matrix. Okay, so this is what order of matrix is. Now the next topic is types of matrices. Okay, so we basically have multiple types of matrices, but I won't be go through all of them because they are actually not important. Basically, these are just the names of matrices based on how they look like. Okay, so I will tell you about the important ones and the ones that we are going to use inside the Houdini, right? So the first one is row matrix. So let's say we have a matrix that looks like this: 1, 2, 3, 4. So you can see this matrix has only one row and 4 columns, right? This one row and 4 columns. So this matrix is called a row matrix, right? And similarly, if we have a matrix that looks like this: 2, -1, 0, 4. So you can see here it has 4 row and 1 column. So it's called a column matrix. So basically, if a matrix has one row, it's a row matrix. If a matrix has only one column, then it's called a column matrix. So you can see here they are named based on how they look like, right? But at the end of the day, these are just matrices. Okay. Now the next matrix we have here is square matrix, and as you have guessed, it has same number of rows and same number of columns. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13, 14, 15, and 16. So you can see here it has total 4 rows and 4 columns, right? It has these 4 rows and total 4 columns. So it's called a square matrix. Okay, so when the number of columns and number of rows are same, then this type of matrix is called a square matrix. And in Houdini, we see this matrix a lot. I think you are going to, as a beginner, you are going to use this type of matrix only. So remember it. Okay. And the next important type we have is here is a unit or identity matrix. So now let's create a square matrix here: 1, 0, 0, 0, 1, 0, 0, 0, 1, and it has order of 3 cross 3. So when a square matrix has all the diagonal elements 1 and all and rest of the elements 0, then this type of matrix is called a unit or identity matrix. Okay, so let me repeat it again: when all the diagonal elements 1 and all the rest of the elements 0, then this type of a square matrix is called a unit or identity matrix. Just remember one thing: this matrix needs to be a square matrix. Okay, so this is what different types of matrix are and that we are going to use. And in Houdini, basically we are going to use only this square matrix and this identity matrix, and we are going to use them a lot. So just remember about them. Okay. So the next thing we have here is a property of identity matrix. So basically, let's say this is our identity matrix. Okay, 1, 0, 0, 0, 1, 0, and 0, 0, 1. Okay, this is our identity matrix. Let's call it I. So when we multiply any matrix by an identity matrix, we get the original matrix in return. And don't worry, I will explain how this multiplication works, but just remember it. when we multiply any matrix by an identity matrix, we get the original matrix in return. Even if you do it something like this also, when identity matrix is multiplied by an matrix, we get this same matrix in return. Okay. So this is a very important rule, and just remember it. And once we dive inside in Houdini, we will see this in action. Okay, so this is the property of identity matrix that I need to tell you. And the next thing we have here is a transpose of matrix. Okay, so let's say, let me find a space here. Okay, so let's say we have a matrix that looks like this: 1, 2, 3, 4, 5, 6, 7, 8, and 9. And this first element, let's call it A11 because it's in the first row and first column. Let's call this element as A12 because it's in the first row and second column. And let's call it A13, and similarly let's call it A21 because it's in the second row and first column. And this one will be A22, second row, second column. This one will be A23, second row, third column. This one will be A13 because it's in the, sorry, A31 because it's in the third row and first column. Let's call it A32, and this one will be A33. Okay. So let's call this matrix M, right? So to find the transpose of this matrix, basically we interchange the position of row with column. Okay, the column becomes row, the row becomes the column. That's how we find the transpose of a matrix. So for this first element 1, you can see its column and row number is same. So even if we exchange their position, it will remain in the same position, right? But let's talk about this 2 here. So it's in the first row and second column. So if we interchange their position, it will be in the second row and first column. So it will this element will now be here. And similarly for this 3 here, it will be in the third row and first column. So it goes here. And similarly for 2 here, it will be in the first row and second column. So it goes here. And this similarly 7 goes here. And 5 remains in the same position because it's in the second row and second column. So even if we interchange this, the position remains the same. And 6 will come here, and 8 goes here, and 9 remains in the same place. So you can see here the diagonal elements remains in the same place, but the elements above and below interchange their position. Okay, so that's how we find the transpose of a matrix, right? By interchanging the position of rows with columns and columns with rows, right? And okay, so this is a transpose of a matrix. And the next thing and the last topic that for this video is addition, subtraction, multiplication of matrix. Okay. So before I begin, let me tell you, for addition and subtraction, the order of the matrices that we are going to add or subtract needs to be same, right? So if we want to add these two matrices or subtract these two matrices, the order must be same. It must be A cross B, then this one should also be A cross B. Okay, this means the number of rows and columns in this matrices must be same as the number of rows and columns in this matrices also. Okay, for addition and subtraction. So let's say we have a matrix 1, 2, 3, 4. Now let's add this to 6, 7, 8, and 9. This matrix here. So you can see this is also a 2 cross 2 matrix, and this is also 2 cross 2 matrix. So for addition, we basically add the corresponding elements, right? And even for subtraction also, we do the same thing. For addition and subtraction, we basically add or subtract the corresponding elements. So like this. So what we get? 1 plus 6, 2 plus 7, 3 plus 8, and 4 plus 9. So what we get? We get 7, 9, 11, 13, and this order also will be 2 cross 2. Okay, so that's what we get here. And similarly for subtraction also, let's see, we have a let's create a matrix here. 6 minus 1 2 0 subtracted by 3 1 4 2. Okay, let's subtract these two matrices, and we see here the order of these two matrices are same, so we can subtract them. So what we get? 6 minus 3 minus 1 minus 1, 2 minus 4, and 0 minus 2. So what we get? 3 minus 2 minus 2 minus 2. Okay, so this is what we get as a result, okay, for from the subtraction of these two matrices, right? So that's how we do the addition and subtraction. Now let's talk about the multiplication. Multiplication of matrices, right? So basically there are two types of multiplication we do. First we do a scalar multiplication, which means basically a scalar multiplied by a matrix. And the second thing that we can do is where we multiply a matrix with another matrix. Okay, so basically we have two types: scalar matrix multiplication or a matrix multiplication. Okay, so let's talk about this first one here, where a scalar will be multiplied by a matrix. So let's say we have a scalar value of 3 here and a matrix here that look like this 2 3 4 5 6 and 7. Okay, so this is our 2 cross 3 matrix. Now let's multiply it. So when we multiply a scalar value with a matrix, basically all the elements gets multiplied. So what we get? We get 3 multiplied by 2 6, 3 multiplied by 3 9, 3 4 are 12, and 3 5s are 15 and 18, and similarly 3 7s are 21. Okay, so that's what we get. So basically when we multiply a scalar value with a matrix, then all the elements of the matrix will be multiplied. Okay, now let's talk about the matrix multiplication. So let's say we have a matrix here with the order of A cross B multiplied by a matrix order of C cross D. So for a matrix to be multiplied with another matrix, the number of columns in the first matrix needs to be same as the number of rows in the second matrix. Okay, let me repeat it again. If you want to multiply two matrices together, then the number of columns in the first matrix must be same as the number of rows in the second matrix. Okay, and the final result that we get after the multiplication, this matrix that we get after multiplying these two, its order will be A cross D. Okay, okay, so just remember it. Now let's see an example here. So let's say we have this matrix here 1 0 1 minus 1 2 3 2 1 4. Okay, now let's multiply this by 0 0 1 minus 1 2 1 4 2 1. Okay, so as you can see here, its order is 3 cross 3, and this matrix order is also 3 cross 3. So we can see here the number of column here is same as the number of rows here, so we can multiply them. And okay, so before I begin, let me tell you how this multiplication actually works. So to multiply these matrices, basically what we do, we multiply this whole row by this whole column, right? And we do this for all the columns here. First we multiply this whole row by this column, then by this column, and then by this column. And similarly, we do this thing for all the rows here. Okay. So now let's just see this in action so you can understand it better. So what we get basically here. So first we multiply this whole row by this whole column based on the corresponding elements. Okay. So first 1 is multiplied by 0. What we are doing, we are multiplying this row by this column. Okay. First 1 is multiplied by 0 plus 0 multiplied by minus 1. Then plus 1 multiplied by 4. Okay. Remember to add the addition here because that's how this things actually work. This is the rule how we multiply a matrix. Okay, we multiply row by the corresponding columns, and then the multiplication takes place between the corresponding elements here, and we do the addition, of these multiplications here. Okay, so now this is the that's how we get the first element of this output matrix, output final matrix. Okay, now for the second element we similarly multiply this whole row by this second column here. So what we do, 1 multiply 0 plus 0 multiplied by 2 plus 1 multiplied by 2. For this third element, we multiply this whole row by this third column here. So what we get? 1 multiplied by 1 plus 0 multiplied by 1 plus 1 multiplied by 1. Right? Now for this this element here, what we do? We multiply this row again by these three, by this column. So what we get? Minus 1 multiplied by 0, 2 multiplied by minus 1, and 3 multiplied by 4. Similarly, for this element here, we get what we do, minus 1 multiplied by 0 plus 2 multiplied by 2 plus 3 multiplied by 2. And similarly, for this element here, we multiply this whole row by this whole column. So minus 1 multiplied by 1 plus 2 multiplied by 1 and plus 3 multiplied by 1. Okay. Similarly, for this element here, we multiply this row again by this column. 2 multiplied by 0 plus 1 multiplied by minus 1 plus 4 multiplied by 4. And again, 2 multiplied by 0. Now we are multiplying this row by this column here. 2 multiplied by 0, 1 multiplied by 2, and 4 multiplied by 2. Again, for this last element, we multiply this row by this column here. So what we get? 2 multiplied by 1 plus 1 multiplied by 1 plus 4 multiplied by 1. Okay. So the final result that we get after multiplying all this is this is 0, 0, 0. Oh, okay. So what we get? 4 here, and here we get 2, and in here we get 1 plus 1, 2, and here we get minus 2 plus 12, that will be 10, and here we get 4 plus 6, that will be 10, and here we get minus 1 plus 2, so that will be 1 plus 3, that will be 4, and here we get 0 plus minus 1, that will be minus 1, plus 16, that will be 15, and in here we get 2 2 plus 8, that will be 10, and in here we get 2 plus 2, that will be 4, 2 plus 1, that will be 3, 3 plus 4 will be 7. Okay, so that's what we get as an output, and its order will be 3 cross 3, right? Okay, so that's how we do the matrix multiplication. Just remember one thing, the number of columns in the first matrix must be same as number of rows in the second matrix, and the final output that we get will have order of A cross D, like this here. Okay, so this is it for this video, and I think we have covered all the basic concept here, and in the next video we will cover more theory of this matrices, and we will see some Houdini specific theory also in our next video. Okay, so this is it for this video. I hope you find it interesting, and if you like this video, please do subscribe my channel, and stay tuned for the next videos. I think I will post it in the next Sunday, and okay, thank you for watching it, and okay, bye, see you in the next video. Bye bye.